Hey guys, and welcome back to my series on solving other equations. This is the last video in this series, and we're going to take a look at absolute value. So let's hop right in. So when we're first learning about absolute value in math courses, we are taught it as a piecewise function. So the absolute value of x is equal to x if x is greater than 0, and is negative x if x is less than 0. And this makes sense because if we think about the absolute value of 2. Here, 2 is greater than 0, so the absolute value when x is greater than 0 is 2, right? And if we have the absolute value of negative 3, well here, negative 3 is less than 0, so it's equal to negative x. So this is equal to negative 3, which of course will give us 3. So it's a fancy way of saying basically it's always positive, regardless of what's inside the absolute value. We're going to take the positive result. But that doesn't mean that what's inside the absolute value can't be negative. In fact, lots of times it is. So when we look at something like this, which is an absolute value equation, the absolute value is of x is equal to 4, well, the answer is x is equal to plus or minus 4, because if we have the absolute value of negative 4, then our x is less than 0, so we have negative 4, and that gives us 4. And if we have the absolute value of 4, then that's greater than 0, so that's just x, so that's 4. So either way, right, if x can be negative 4, what's in here can be negative 4 or 4, and the equation will hold true. So when we solve absolute value equations, we typically make two equations. So in this case, the absolute value of 2x minus 3 equals 11. We have 2x minus 3 is 11, or 2x minus 3 is negative 11, because what's in the absolute value is equal to 11, which means what's in here, this 2x minus 3, can be a positive or negative 11, and then when we take the absolute value, it'll still equal 11. So when solving these equations, we're going to make two separate equations and solve for them. So let's go ahead and look at some examples. So here we have 3 times the absolute value of 2x minus 1 is equal to 21. Well, the first thing we want to do is that the whole left side is not in absolute value. So we can't just say 3 times 2x minus 1 is 21 or negative 21, because the entire left side is not in absolute value. So if we want to separate it into two equations, we have to have this whole thing be in absolute values. Just like before when we wanted, with radicals, if we wanted to square it, we needed the square root to be by itself on one side. Same concept here. So how do we do that? Well, we divide both sides by 3, and we get the absolute value of 2x minus 1 is equal to 21 divided by 3, which is 7, which will then give us our two equations, which is 2x minus 1 is either 7 or 2x minus 1 is negative 7. Now in this first one, adding 1 over, we'll get 2x equals 8, and dividing the 2, we'll get x is equal to 4. And in this one, adding 1 over, negative 7 plus 1 will give us negative 6. Dividing by 2 will give us x is equal to negative 3. And then we can see that if we put that back in, we have 3, we have 2 times 4 minus 1, and that's going to give us 2 times 4 is 8, 8 minus 1 is 7, so it's going to be 3 times the absolute value of 7 is equal to 21, and the absolute value of 7 is just 7, and 3 times 7 is 21, so we can see that that's correct. And if we look at our other answer, we have 2 times negative 3. Now this is going to give us, should give us 7 again, right? Because the only thing we can multiply by 3 to get 21 is 7, but we know that the absolute value of negative 7 will also give us a positive 7. This is going to give us 3 times the absolute value of negative 7, and we can see that because 2 times negative 3 is negative 6, minus 1 is negative 7. And again, since the absolute value of negative 7 is 7, we end up with 3 times 7 and 21. So as you can see, both of our answers are correct, and that is our solution set, negative 3, 4, and it satisfies with the absolute value. And that's really all we're looking for. We're looking for what number will give us the positive result, what number will give us the negative result, because we know that both results, just like when we take the square root, we need to think of the positive and the negative. Same thing here. both a positive 7 and a negative 7, when we take the absolute value of it, will give us a positive 7. And when we multiply by 3, that'll give us 21. So that's really what we're looking for, the positive and the negative. So let's go ahead and run through a few more examples. Again, we have a lot of terms over here. We have 7 multiplied by the absolute value of 3x plus 2. And to separate it into two equations with a positive and negative, we need to just have the absolute value. So we subtract 2 from both sides, and we have 7 times the absolute value of 3x is equal to 14. Then dividing both sides by 7, we'll get the absolute value of 3x is equal to 2. And from here, we can make our two equations. We have 3x is equal to 2, or 3x is equal to negative 2. Dividing by 3, we get x is 2/3, or x is negative 2/3. And let's go ahead and check that out. So we have 7 times the absolute value of 3x plus 2 equals 16. We'll first put in 2/3, so 3 times 2/3 is going to give us, these 3's are going to cancel out, and it's going to give us 7 times the absolute value of 2 plus 2. The absolute value of 2 is 2, and 7 times 2 is 14. 14 plus 2 is 16, so we do get that correct response. Similarly, if we put in our negative 2/3, it's going to be the exact same thing, except we're going to have the absolute value of negative 2 instead. But we remember the absolute value of negative 2 is positive 2, so again, we'll get 16. And you can see how we have come up with the positive and the negative values that will make our equation true. Right, so this one is not necessarily more difficult, it's just a little bit more complicated. We're going to do the exact same process. We want to get the absolute value by itself. So we start by subtracting 7 from both sides, and we'll have 4 times the absolute value of 1 minus 3/4 x is equal to 3. Then we'll divide both sides by 4, and we'll have the absolute value of 1 minus 3/4 x is equal to 3/4. So from here, we can obtain our two equations. So we'll have 1 minus 3/4 x is equal to 3/4, and we'll have 1 minus 3/4 x is equal to negative 3/4. Now, we want to subtract 1 from both sides as our first step to solve for x. And we want to remember that 1, since everything else is in fourths, we want to be in fourths, is equal to 4/4. So when we subtract 1 on this one, we'll get negative 3/4 x is equal to 3/4 minus 4/4 will give us negative 1/4. The same thing over here, we'll have negative 3/4 x. This time we have negative 3/4 minus 4/4, same as negative 3 minus 4, which will give us negative 7 all over 4. Now we can multiply by 4, both sides of the equation by 4, and that'll give us a negative 3x is equal to negative 1. Dividing by negative 3, we'll get x is 1/3. Doing the same thing over here, multiplying both sides by 4, we get negative 3x is equal to negative 7, and dividing both sides by negative 3, we get x is equal to 7/3. So our solution set in this case is 1/3 and 7/3, and you can plug that right back in. It'll make it really easy because the 1/3 and the 3/4, that'll cancel out. You get 1/4, so it should make it, which will then cancel out with the 4 that you're multiplying by. So it should be pretty easy to check, but I'm going to go ahead and leave that to you so we can run through a few more examples. All right, so it doesn't always work out, and a lot of times we can tell that it won't work out. Now we know that the absolute value is always going to give us a positive result, but there's no way, there's no positive number that we can add to 6 to get 2, because 2 is less than 6. The only way that we can add 6 and get 2 is if we have a negative number. So we can tell right here that this problem will have no solution. or the solution is the empty set. Because there's no positive number. And we can see what will happen here is if we try to get the absolute value by itself and we subtract 6 from both sides, we have the absolute value of x plus 1 is equal to negative 4. Well, we can't just then say, okay, well, we have negative, so then we'll have 1 will be equal to negative 4 and the other will be equal to negative 4. We can't do that because we know that this absolute value will always produce a positive number. So there's no x that we can put in here that when we take the absolute value, we'll get negative 4. So this has no solution. We're going to look at one last problem. So here we have the absolute value of 3x minus 2 plus 4 is equal to 4. Well, the only thing that we can add to 4 to get 4 is 0. So we know that that's going to be 0. But if we go ahead and try to solve it in the same fashion we did the other, we could subtract 4 from both sides, in which will give us the absolute value of 3x minus 2 is equal to 0. And at this point, we'd set up two equations. We'd do 3x minus 2 is equal to positive 0. And 3x minus 2 is equal to negative 0. But as we know, there's no positive and there's no negative 0. So simply 3x minus 2 is equal to 0, and solving for x will give us our solution. Adding 2 to both sides, we have 3x is equal to 2. Dividing by 3, we have x is equal to 2/3. So in this case, our solution set is just one number. In all of the other examples, we had two solutions because we had to consider both the positive and negative. Then the previous example, we had no solution, clearly. And in this one, we have one solution. So this is just to make sure that you're clear that it won't always be two solutions, that you do also have to pay attention. Sometimes there may be no solution, and again, sometimes there's just one. Thank you so much for watching. This concludes the video on solving other types of equations and equations involving absolute values. It also concludes the series on solving other types of equations. I hope you got a chance to check out all the videos and I hope you like them. Please feel free to ask questions, like, and share, and I will be uploading new videos on different topics soon. Thanks again.